All right. Oh, just be in front of it. If you're talking loud enough, you don't have to use the handheld. But I'll get a thumbs up and thumbs down for the student volunteer.
All right. Okay, I'll get started. Hello, everyone. I am Nilesh.
Thumbs up or down on the back? Thumbs up. Okay.
Right. Hello, everyone. I'm Nilesh. I work at Google. And my team works on an experimentation platform that we call search evaluation. This platform is used by Google Search, but a lot of other Google products as well, such as YouTube, Google Play, Maps, Lens, etc. So today I want to talk about the platform, but I also want to talk about evaluations, what they are, and how we do them. And I also want to talk about the challenges that we face. Yeah, so what's the purpose of evaluation, right? So the purpose is to generate insights about the business impact of product changes, right? So what does business impact mean? So the way we quantify business impact is through metrics. And metrics could be of different types. Metrics could talk about the quality, they could talk about the impact, so how many users are affected by each change. They could also talk about information satisfaction, which is, does my result page really answer the query that the user has input? So that's information satisfaction. And what do we use these metrics for? We use them for tuning, which is basically iterative changes. We use them for launches. So if the metrics show a positive value, we launch our products. And if also metrics are used for sort of detecting unexpected changes that are missed by other testing means. All right, so who are our users, right? Feature developers are obvious users. So basically anyone who writes a change to Google search will probably conduct some experimentation to make sure that the change does not cause any issues in Google search. The other set of users are metric developers. So metric developers, they keep up with the market and they come up with these new metrics that we should be measuring for and we should be optimizing for. So I showed some examples of metrics before, but those are only 3. But the platform has like hundreds of different metrics, which we use to measure like various different things. The final set of user is model developer. So this is special case of feature developer, but the platform has tooling for testing and experimenting on models. All right, so coming to the platform itself, let me just talk about the general process that is used to evaluate a change. So at the start, we have queries, and then we feed the queries into the system under evaluation. For us, that could be Google search or that could be any other product. And then for each query, there are some results that the SUE generates. And from those results, we create metrics using a process called report generation. Now I'll talk about each one of these in a bit of detail. So yeah, we start with queries. So the queries are basically what the user inputs on Google search, right? So we take them either from production logs and we scrape the user data out of it, we anonymize it, or we synthetically generate queries. So for example, if we know that elections are coming up, we would have a model that sort of generates election-related queries. The other thing is that we curate queries into sets. So there are different sets of queries which are applicable to different locales, different languages, etc. And also different sets of queries which are applicable to a certain type of experiment. I'll talk about sampling a little bit later in the slides, but yeah, coming to the size, so evaluations can run anywhere from a few thousand queries to up to 100,000 queries or more. So we are talking about putting all of this traffic on production servers because evaluations do go through production servers. So it's a lot of scale that we're dealing with for a single experiment. And we do like tens of thousands of experiments every day. Okay. Yeah, coming back to the figure again. Let me talk about the system itself. So the system is basically any service that we are testing. It could be Google search or it could be anything else. But in reality, we're actually testing with two different instances of the same server. So if you are wanting to test a new change in Google search, you would have a base stack, which is basically the vanilla stack. And then you would have a test stack, which is basically, it has your change integrated in it. And you would run the same process through both of these stacks and collect the results from both of them, and then do analysis of them. Yeah, so we allow users to specify how to build each stack. So the left side, like what goes into the left side, what goes into the right side, etc. One important thing is that for building the stacks, we prefer that users start with a qualified green CL, which is basically a CL that we have qualified based on our CI testing and our smoke testing, etc. And so every binary has a green CL, and we want users to start with green CL and then patch their changes. There are other customizations as well that you can do. For example, you can specify how many sides you want to test. You could test 2 sides. You could also test 3 sides, although I have not seen anyone test 3 sides, but it is possible. You can also customize the requests that go into each side. So, for example, if you want to set a feature flag in the request to one side, you can do that. Finally, we have sampling. So sampling is basically used for the case where users tell us that run as many queries as you need to, but give me the first 100 diffs or the first 1,000 diffs. So then the system will run like hundreds or thousands of queries and then just find the 1,000 that actually have a diff in them. All right, so results. Yeah, so we, as you can imagine, we do have a lot of results generated from this whole process. So a 50K query set evaluation would generate 1 million results. And so we are having to manage a lot of data through this pipeline. All right, so now that we have results, what do we do with that, right? We want to create metrics. So we want to make sense of these results, and we want to do some analysis on these. That's where the report generation comes in. So the report generation is actually 2 steps. One of them is where the magic actually happens. That's the rating generation step. So what we do is that for each of the results that we found, we give a score to each one of them. So the score would say something like on 0 to 5, how good is this result, right? And there's a process to generate those scores, which I'll come to soon. And then once you have scores for all these results, you aggregate them using a formula. That's metric computation, where you apply a formula to these individual scores, and you sort of make higher top-level scores that users can look at and say that, yes, this is a good change or is it a bad change. All right, so rating generation is the stage where a lot of the magic happens. So for each of the results, what we do is we create a questionnaire, right? We create a questionnaire with things like, how satisfactory is this result? Or what is the quality of this result? Or it could have any number of questions. And we send that question to a human rater. And the human rater is like, what the human rater sees are these questions, and they're supposed to like mark a score based on their knowledge, and the score would be something like 0, 1, 2, 3, 4, 5. And then we will sort of aggregate those scores. As you can imagine, the human rating process would take a user 2 to 3 days because that's the SLO on it. So what we have done recently is that we have also added AI raters. So AI raters basically sending the same question as a LLM prompt to a LLM model, and the model responds like right away, or maybe there's like a couple of hours of gap between them. One thing I forgot to mention is that we finally cache everything so that if we have a result which is already rated, we don't ever, or we don't rate it for a while again. All right, metric computation again. So like what we're doing now that we have these individual scores for results is that we aggregate them to a query level so that each query has a score. And then we aggregate them again to the query set level so that the experiment itself has a score on top. And then finally, we compute what is called metrics. And so metrics are presented to the user in a UI dashboard. So the users can see like, oh, for my query, this query, here are the results. And each result was scored like good or bad. So users can do a lot of data analysis on the UI. Users can filter certain queries. Users can do slicing of data and whatnot to analyze the data. We also produce the results and metrics in a file on the cloud. So basically, it's an artifact that users can use to do analysis on their metrics offline. Finally, we do have some CI-like features. It's like we are not a full-fledged CI yet, but we do have some features and functionality, some of which we have recently built to sort of enable a similar workflow. The one thing that we've had for a while is for continuous evaluation. And it's basically the evaluation process that I just described, but it's run periodically. And instead of showing numbers for individual experiments, we sort of draw a time series graph and show the numbers with time. So using this, users can see if their information satisfaction metric, for example, started dropping, they can sort of do culprit finding to see where the decline started. Right. Recently, we also started adding some pre-submit checks. Sorry. So Google has this generic pre-submit framework called Tricorder, where you can sort of add pre-submit checks. So our service also has registered in that service. So basically, for a lot of our users, we trigger evals anytime there is a code change. And the most common use case is zero diff evals, where these are evals where we don't expect there to be any differences on either side. So we call them zero diffs, and they are supposed to pass. Basically, for 90% of the changes, there shouldn't be any diffs introduced in production. All right, we have an optimization that we have recently done on the pre-submit workflow. So when the pre-submit starts, we build the SUE, right? So what we have done is that every time the user updates the code, in the background, we will rebuild the SUE. Even before the user starts a new test or a new eval. So that makes sure that the SUE is always up to date. And it saves a lot of time rebuilding it and making it up to date again. All right, I'll speak about some of the challenges we've had. The biggest challenge for us has been resource management because we serve experiments through production servers where live users are also sending traffic. So we don't usually have infinite resources. So we build this priority queue at the beginning of the pipeline. And the queue stops requests from going through until we know that there is enough resources. But even then, we found that this mechanism in itself was not sufficient, because even if you detect that there is enough resources for the eval to happen, evals take several hours to finish. So later in the course of the eval, you may run out of resources. So what we are doing is we are adding more queuing functionality and more prioritization along the pipeline as well. Oh yeah, so the one thing we also did was we propagate a back pressure signal to the front end that has the queuing on it. So anytime we the backends see that we are out of resources, they send an out of resource signal back up, and then the front end will sort of queue more aggressively. Scalability, yeah, scalability has also been an issue because initially when this tool started, we didn't have as much usage out of it. But recently, we just have so many experiments, and we do experiments on every change nowadays. So there's a lot of scalability pressure. Just a bit of a history. So this tool used to be a CLI tool, like a binary that you run locally. And then it would do all of the things that I said, but it would just do it locally. So what we did, the first phase of evolution was to change the service from a local running binary to a cloud-hosted service. So we added a hosted server, where users will send requests, and then we will do the same thing on the cloud. So we will run the binary one-off on a cloud task, but it's still hosted. So that was the first phase of evolution. Starting from there, what we have done slowly is that instead of running a new task for every eval, we just have a long-running pool of tasks that are sort of they are sort of to be used by anybody. So it's not like you get a dedicated set of tasks for your evaluation. We have just a common pool of tasks. These tasks have a leader-follower model. And so what that allows us to do is to just scale up rapidly. We just increase the number of tasks, and it just scales up to the required demand. All right. So a few other challenges as well. So the one thing is that since the tool was initially a binary, so we have a lot of functionality on it, which is very specific to a few users. So it's like maybe one user added some functionality to it, which is only used by their team. But now we have a lot of these functionalities which don't really work well with each other. So what we are doing is we are providing some well-lit paths, and we are discouraging users from using some of the advanced features that we have, unless you really need them. The other thing is error attribution. So the pipeline is very, very big. There's like 50 people working on different parts of the pipeline. So sometimes it's hard to figure out where things are failing. So there's a push to add dashboards and like UI messages to attribute the errors correctly. Another challenge is that for continuous evals, sometimes humans can rate the results incorrectly, or like some humans have bias or something like that. So we get a lot of false alerts. So the recent push for adding AI ratings solves some of that, because AI raters are always more trustworthy, and they give you a more consistent signal, even though it's not always the best signal, but they give you a more consistent signal. With that, I'll come to the end of my presentation, and I'll open for questions.
There's plenty of time for questions, so go ahead. Got one. You go on.
So the error attributions, like what do you do with them? Like you get an alert, you classify the alert, and then what do you do with it?
Yeah, so the team has like 50 engineers, and the pipeline is really distributed into a lot of different subcomponents. So the errors, when they're attributed, the overall on-call for the system will then create tickets for the individual on-call of the pipeline that's actually failing.
And then what do they do? Like, you know what I mean? Like, what's
Yeah, so the errors, so we have an SLO dashboard, and so the error is attributed to that team whose component is failing the most. So then the leads know that we should fund these projects the most and make sure that the reliability of these components is better.
For the presentation. I've got a question because I would like to understand exactly how it's used in the continuous integration system. So is it part of continuous deployment, so it runs automatically for all the changes, or is it something that users have to like explicitly request to run?
Yeah, so it's not integrated in any of the CI systems until very recently, where we add a small amount of evals into this automatically triggered tests. But the way things work at Google is that, or in Google search, is that for every launch or for every change, you need approval from somebody. And for that approval, you would need to show that, hey, look, my change does not do anything bad in production. So you always need to go through an evaluation process.
Then you have to request
Yes, yes. Sorry.
Okay. I want to get a sense of how fragmented is, like, I assume, you know, LLM teams, for example, might have their own A/B testing framework for testing, you know, model revisions and its effects. So how fragmented is the landscape? Like, how much, you know, does Gemini use, you know, your team's
It does.
product? Okay.
It does.
Okay.
So Gemini, I'm not sure of, but for example, I don't want to use the code word for the project, but you see the answers on Google search.
Yeah.
The team that generates the answer on Google search, that team uses our platform. So anything related to Google search will probably end up using our platform.
Okay. Okay. And then I guess the secondary question on top of that is then I think these human ratings that you're talking about, it seems like there might be other A/B testing places where people are using human feedback. And so
Yeah.
I'm curious, is there a lot of data sharing there? Also, this AI rating, is there data sharing on how they've generated an AI rating model?
No, I don't think there is any data sharing.
Okay.
I think Google keeps its data quite separate, and the AI raters that we have trained on top of the human ratings.
Yeah.
And then it's like a feedback loop where
Yeah.
we sort of use now the AI raters to judge the quality of the human ratings as well. So yeah, it goes in circles.
Okay. Thanks.
All right. Yes.
All right. Since I know you were previously a CI person. Okay, so here's the question. How can you make like the practice of software development for things that are a little bit squishier, they need these sort of evaluations. How can you make it more like CI, where it is more continuous? You have the feedback, like tighter development loop, not so much like what are the big challenges to make things where you're doing something like Google search more like regular software development?
Yeah, I think the answer to that would be probably more tighter integration with the release itself. But the thing again is, like, for us, we don't really care as much about release. We care about the launches. So we do have integrations with the systems that approve launches and all that.
Anybody have any more questions? Okay, Mark.
So you mentioned that recently you introduced a pre-submit integration.
Mm-hmm.
My question is, how do you handle oracles with that? So when do you say, well, this change is bad, like it gets like my experiment fails? What is a failed experiment?
Yeah.
What-
So we, like, because of the nature of these experiments, right? So we can't really do every kind of experiment with a pre-submit. So what we use right now for pre-submit is mostly what we call zero diff evals, where because 90% of the changes are not supposed to create any production impact. So we just use zero diff evals as a pass-fail signal for detecting that.
So it's just like you're asserting that performance has stayed constant.
Yeah, not just performance. It's also like everything. For example, whatever metric it is. Yeah. So we just make sure that your change is not really shifting the metrics a lot.
And then do I have to indicate like when I make a change where I would expect it to?
Yeah. Then you have to add certain tags in your description or say something
Okay.
where you say that, oh, this is expected or something.
All right. All right, so we will go to coffee break now. I want to thank just one more time all of our presenters. So thank you for everybody who presented today, and to everybody who did not present but is attending. I hope you found value. If you did, let me know. And you're definitely welcome to everybody's, it's open steering. So during that time, if you want to get involved in this community or you have suggestions for how we can make the workshop better, we are absolutely open to your needs. So if you found value, especially, let us know. Okay, so half an hour, I think. And we'll be back here at 4 p.m. or 1600. All right.
Share again.